Anushka Shukla of ANC5 presenting to you the research capstone, which was based on vehicular ad hoc networks. Talking about VANET, it refers to a network created in an ad hoc manner where different moving vehicles come in contact over a wireless medium and exchange useful information with one another. This figure shows how a vehicle is equipped with an onboard sensor and an ECU, the electronic control unit, which gathers all the information and transfer it to connected nodes. Majorly, there are two types of communication, V2V and V2I. In V2V, the vehicles are connected to each other via wireless medium, while in V2I, the vehicles communicate with the RSUs present in their range. Now, we will here focus on vehicle to vehicle communication. The figure shows the architecture of the VANET. Each layer has its own function, but we will discuss upon the max sub layer of the VANET, which is responsible for various tasks. Now, the communication between V2V and vehicle to infrastructure, which the MAC layer is responsible for, is provided using a wireless medium called WAVE, that is wireless access in vehicular environment, which is also known as IEEE 802.11p. But it has some limitations, due to which various MAC protocols have been developed over the years to reduce the overhead and improve the quality of service, one of which is cluster-based MAC approach. Cluster-based MAC protocols take the dynamic nature of VANETs into consideration and try to achieve reliable communication by forming small clusters, as shown in the figure. Each cluster has a cluster head depicted by the blue vehicle and the cluster members by the red ones. The cluster head acts as a coordinator for the rest of the members. Hence, when the cluster head leaves, it disassociates all the members and creates an unstable environment. And to avoid this situation, we propose the following model. This slide shows the state diagram for the proposed model. So, the SINR is the signal to noise ratio, which depicts the quality of the signal. Hence, we define two bounds on the SINR of cluster head, the upper bound TA and the lower bound TB. Hence, whenever the cluster head will go farther away from the cluster, it will result in the drop of SINR. Now, if it goes below TA, the head will start searching for, it will transmit an initiation message for all the members to send their SINR. And after the SIFS period, it will check its SINR. If the current head's SINR is above TA, that is above the upper bound, it will remain the cluster head and the situation will be stable. But if it falls below the lower bound, that is TB, the cluster head will hand over all its responsibility to the member with the highest SINR and will transmit a completion message. The cluster head then leaves and the new cluster head broadcasts a message to all the members that now it is the cluster head. Thank you.